Hey, what's up, everybody? Welcome back to another episode of Hacking Smart Contracts for Fun and Profit. Today, we're going to be looking at challenge number 8, Puppet, from Damn Vulnerable Defi. So, there's a huge lending pool borrowing damn valuable tokens, where you first need to deposit twice the borrow amount in ETH as collateral. The pool currently has 100,000 DVT tokens in liquidity. There's a DVT market open in a Uni Swap V1 exchange, currently with 10 ETH and 10 DVT in liquidity. Starting with 25 ETH and 1,000 DVTs in balance, you must steal all tokens from the lending pool. Okay, let's check it out. Okay, so here is our contract. So at the top, we're just importing a couple things down into our contract. We're inheriting from reentrancy guard. We have a mapping called deposits. It takes an address, maps it to a uint. Then we have a reference to the Uniswap pair, and then we have a reference to the damn valuable token, or an instance, I should say. So lastly, we have an event borrowed that just emits an event when we borrow something from the pool. Okay, so getting into the constructor, we just have the token, we have the Uniswap pair, they're just being initialized here. And then we get into our first function called borrowed. So here we have the modifier no reentrance. And then we have a variable here called deposit required equal to calculate deposit required, and then the borrow amount. So let's find this helper function and let's find out how exactly this is being calculated. So down here, we see this helper function, calculate deposit. So it returns the amount multiplied by the compute oracle price. So once again, let's just find out how this stuff is being calculated. Let's just follow this down sequentially. So next, we have to look for this, which is right below. We find the compute oracle price, which returns the Uniswap pair dot balance, which is how you retrieve the ETH balance. So this is going to give us the ETH balance, and then here, this is our token balance. So basically, and then this multiplication here is adding the 18 zeros we need to get to the ERC20 standard, because as I've mentioned in previous videos, Solidity doesn't work with floating point numbers. So this is how we get the amount of decimals we want to work with here. We just add this 10 to the 18. So if we kind of just forget about these decimal places, so to speak, right here, we basically have the Ethereum balance divided by the token balance. And as we saw here, it is 10 ETH and 10 DVT. So essentially that will give us 10 divided by 10, which equals 1. So we can take this oracle price is 1, and then we can place this here, and then it will just be the amount multiplied by 1. So for the sake of simplicity, say the amount we want to borrow is 10. That would be 10 multiplied by 1, which gives us 1, and then multiplied by 2, which is going to give 20. So if the borrowed amount is, as we request here, we're calculating the deposit required for the borrow. So say we want to borrow, the amount is 10, it would be 10 multiplied by 1 times 2, which would give us 20. So we would need to deposit 20 Ethereum to borrow 10 DVT. And then we just divide this by, this is the amount of decimals. Because we'll actually have, this will give us more than 18 decimals actually here. This will give us like 36 decimals, I guess. So to break it down back to the 18 decimals, this is, we'll have to add some zeros and then take some zeros off to get it back within the working range that we're looking for the decimal places. I hope that makes sense. I think if you work with Solidity, this kind of all makes sense to you. This is pretty standard stuff. So essentially, this is just returning twice the, it's giving you just doubling the number, whatever you're trying to borrow, which is what it said in the beginning. Okay, so back here, we can follow this. So we know how to calculate this number right here. Next, we have a check here. We require the message value to be greater than or equal deposit required. If not, it's checking to make sure we're depositing enough collateral. If not, it's going to fail and give us this error here. Next, we have a check here. If the message value is greater than deposit required, it's going to actually send us back the extra that we deposited. So if the deposit required is 20 and we send in 30, this is going to be basically 30 minus 20, which is 10, and then it's going to send us back the extra money, which is nice of them. They could just keep it. And then after they check to see if there's any extra, then they do some accounting here. This is the mapping above, where it's looking at the deposits and mapping it to a uint. So it's just doing some accounting. And then finally, we transfer the requested borrow amount right here. And we make sure this goes through. If the transaction doesn't go through, we get an error. And then finally, we just get the borrowed, we emit a borrowed event here. Let people know there was money taken out of the pool. Okay, so that is the contract. So basically, what is happening here is the attack vector we're going to go after is a price manipulation attack, which is a very prevalent, even in today's world of DeFi. It happens a lot. Like, I was reading a blog article the other day that, it was a price manipulation attack on a newer protocol, and it got drained for millions and millions of dollars. So basically, the way it happens is either there's flawed logic or there's bad math, I guess, going on. And I just made some notes to kind of walk through some of the ideas here, and I hope this will make more sense. So, actually, before I get to this too, if you want to go deeper on understanding price manipulations attacks, there is a talk here by our man Tincho, who is also the creator of Damn Vulnerable Defi. He does a whole talk here on the Chainlink hackathon. It's called Price Manipulation Attacks from First Principles. So just Google that, watch this talk, and he goes really deep into the whole concept. Really good. I highly recommend it. Okay, so let's go back to my notes. All right, so before the trade, we have 10 ETH and 10 DVT in balance, which gives us a ratio of 1-to-1. 1 ETH equals 1 DVT token. Pretty self-explanatory. What we're going to do is what we want to do, and what people do in these price manipulation attacks is they devalue one side of the pool, and then they will borrow against that, or they'll buy against a devalued token, basically. And I'll show you how we do that. But that's the whole concept behind it. Right now we're going to devalue the DVT token massively, and then we're going to use our ETH as collateral to borrow against this massively devalued token. So we'll just follow my notes here a little bit. So before the trade, we have a 1-to-1 ratio. What we're going to do is we're going to send 1,000 DVT tokens into the pool, and we will receive 9.9 ETH for that in return. So on the on the offset, that seems like a really bad idea, but you'll see as we go on, we're going to, it's going to work out in our favor. So after we trade the 1,000 tokens into the pool, we'll be left with 0.1 ETH and 1,010 DVT tokens, which gives us a ratio of 1 ETH to 10,100 DVT tokens. So now we have massively devalued DVT tokens in this pool. So if we want to borrow 100,000 DVT tokens now, the collateral needed will only be 19.8 ETH. Before, we would have had to borrow 100,000. We double that would have been 200,000 DVT, or 200,000 ETH would have been required to borrow 100,000 DVT. Now we only require 19.8 ETH, because 19.8 ETH times 10,100 is equal to 199,980, which is double the amount of the pool. So that's as close as we can get to the 200,000, because if we request more than in the pool, we'll run into that error we saw before, that there's a check that makes sure we're not trying to borrow more than what's in the pool, and this is as close as we can get. So there'll be a little bit of leftover tokens in the pool, but we can get those out, as we will see when we get to the code. Okay, so just pause that, maybe take a look at these notes, and I hope that makes sense to you. So we will just get into the code, and we'll hack it. Okay, so let me just copy some of the start of this, just to speed it up a little bit. We actually don't need this. Okay. So first we will need an interface for the pool. Let's call it iPool. We will need this borrow function. Change this to external, because that's how Solidity likes it. Oh, missing an F. And we will also need this calculate function here. Okay. Okay, so that is it for our pool interface. Next, we will need an interface for Uniswap, because that is where the pool is that we're going to interact with. So to get the Uniswap interface here, I got the interfaces pulled up on the Uniswap website. You just look at the docs. This is the docs for the Uniswap site. This is the V1, and then you just go down to the interfaces, and we have all the interfaces here that we can use. So we're going to need two functions to interface with. The first one is going to be this one, token to ETH transfer input. So put that in there. And then I like to separate this down onto different lines, makes it easier to read. Okay, so that's good for that. And then we will need one more interface called ETH to token swap input. Okay. And then also I will separate these onto separate lines. Okay, so that is good for that. So those are our two interfaces we're going to need to interact with. Next, we'll just start setting up our contract. We call this Puppet Tack. So first we will create some variables. Pool, call this pool. Uniswap, call Uniswap. We'll need the damn valuable token, call this token, and we will need a reference to our attacker EOA. Okay. We will set up our constructor. Oops. Set up the constructor. We'll give it an input for these references. iPool, Uniswap, Uniswap, damn valuable token, and the attacker. Oops. An attacker, yeah. Okay. Next, we will initialize all of these references and interfaces. So we will say pool equal to pool. Uniswap is equal to Uniswap. Token equal to token. And the attacker is equal to attacker. Okay. So now we have initialized all of our interfaces. Next, we will just get right into the attack and call it attack. We don't need to pass it any sort of inputs. We do need to make it external, and we can make it payable. Okay. So let's just list out the steps we're going to do here. First, we need to transfer tokens into attack contract. Next, we will need to approve next approve the attack contract for Uniswap. After we approve it, we will transfer tokens into pool to offset dynamic, I guess. Why not? We'll just be a little more specific. Next, after we offset the dynamic, we'll need to calculate collateral. After we calculate the collateral, we can borrow tokens. And then after we borrow the tokens, the last thing we want to do is transfer tokens to attacker EOA. Okay, I think that is the steps. Yeah, that looks good. So let's just code it up. So we'll say transfer the tokens, transfer from. We'll transfer from the attacker EOA into this address for the just balance of attacker EOA. Okay. So once we have the tokens, we can approve the tokens. We will approve Uniswap. We approve Uniswap. And we will just say approve it for the max. Uint 256.max. Okay. So once we approve Uniswap to spend the tokens, we can just transfer the tokens. We want the token to ETH the amount sold. So we just want to transfer all of the tokens in our address. Next, the minimum ETH we want. It'd be nice if we get at least 1 ETH back. It doesn't really matter. We could say 0 if we wanted to. And we will just go block, timestamp, say plus 500 seconds. And then, and then the recipient, the recipient is going to be our attack contract here. I'll just move this down onto different lines just so we can read it a little bit better. Okay, that looks good. Next, we need to calculate the collateral, but first we need to get the pool balance, which I'm going to call pool bal. Getting ahead of myself. We just say token dot balance of address pool. Yep. So once we get the balance of the pool, we can calculate the collateral. I'm just gonna call it collateral. It's equal to pool.calculate collateral, and then I will pass it the pool bal. Okay. So once we get the amount we need to deposit, we can just borrow. I'll just say pool.borrow, and then I'll say I want the whole pool. And we need to attach our collateral onto this. So the way we do this is we put some curly braces, then we say value, and then we just say collateral. Collateral. Oh, and I need to spell it right. Okay. So this will attach our collateral in ETH, and we will borrow the total amount of the pool. So once we do that, this will give us the majority of the pool, pretty much everything, but there'll be a few tokens left over. So we can just buy those tokens because we want to just take the whole pie. And the way we do that is we need to use our other interface. This is the ETH to token swap. The minimum tokens we want is 1, say, and the block dot timestamp, our deadline, the same as before, like 500 seconds. I mean, we could probably, yeah, it doesn't really matter. This is just an arbitrary number. Okay, and we also need to attach a value onto this. So the value we need to attach whatever. We can just send it like this. We can say address this dot balance. Okay, and this will attach a value onto this transaction, and it should send us whatever is left in the pool. Okay, that looks good. And the last thing we need to do here is we need to use the receive function, which is a built-in function to Solidity, which allows us to receive ETH. We need to make it so we do it like this. And then, yeah, this function, if we don't have this function here, this contract would not be able to receive any Ethereum. So this is important. And that looks good. Okay, nothing's highlighted. I think this is good. Okay, cool. So we'll save that, and then we will just code up our test. So we will call this hack equal to await ethers dot get contract factory. We called it puppet attack. We need to make it from the attacker, and then we chain a deploy onto this, a deploy function. And we need to set it up in the same way we did in our constructor. Here, where is it? In our constructor, so we did pool, Uniswap, token, attacker. So that's how we need to set this up. This dot pool, lending pool, dot address, this dot Uniswap exchange dot address, this dot token dot address, and then just the attacker dot address. Okay, cool. That should be good. Next, we need to approve attack contract. Attack contract to spend tokens. Because the attack contract is going to call our attacker EOA, and it's going to transfer our tokens out into itself. So when you say this dot token dot connect, because we need to connect the attacker wallet, and then we say approve. We approve this dot hack, which is our attack contract, and we approve it for the attacker initial token balance. Okay, so once we have it approved, the attack contract will be able to transfer tokens out of the attacker EOA to itself. And then once it has the tokens, it will be able to execute the attack. And we'll just say hack attack. Hack dot attack. But we actually need to attach Ether. We'll send besides the tokens, we also need to send the Ether into the contract because it will want to spend that as well. So the way we attach the value is like so. We'll say values ethers.utils.parse ether, and then we say 24.5, because we start with, we can go up here and we start the attacker contract. It starts with 25 ETH, but we need to save a little bit for gas fees. So we will just send it 25.4. We could send it, yeah, I mean, a little bit less. It only needs 19.8 ETH for the collateral, but we'll just send whatever we have into it. And that should be it. Okay, that looks good. All right, let's hack it. Here we go. Moment of truth. Yarn, run, puppet. Okay, let's see. Okay. Compiling. Successful. Okay. Oh, what do we do wrong? Assertion error, hex. Looks like an error in our test, perhaps. Let's check it out. Oh, there maybe. I just need to wait. Some awaits. Prove. Token connect. Prove. Okay, I think that's good. Let's try it again. Let's try that again. Okay, come on. Ooh. Expected 0 to be greater. Okay, let's check our contract. Let's go back to the top. Let's see, we transfer from, we approve Uniswap. Swap token. Looks good. Borrow token to this looks good. This looks good. Where did I go wrong? Let's see. Token dot max. Get the pool balance. Calculate. Oh. Oh. I got ahead of myself here. I I said transfer. I said transfer here. This is code, you know, when you code and you're talking and you're doing all this stuff, it gets a little confusing sometimes. But here we will want to transfer leftover ETH for tokens. This is what we want to do here. I probably said it and it was probably confusing at the time. I was skipping ahead. So this is right here. We are just transferring our leftover ETH for tokens here. Okay. The last thing we want to do, we want to transfer tokens to attacker EOA. So we'll go token dot transfer attacker EOA and token dot balance of address this. Okay. Missed a step there. Okay. So now that should be good. That looks a little bit more like it should. Okay. All right, let's try that again. Here we go. Compiling, successful, that's good. Oh, and we passed. Okay, so that is it for the Puppet Challenge. I hope you enjoyed it. I hope you learned something about price manipulation, and we will check you on the next one.